Okay, welcome. This is my second part of the lecture on the cloud. So, some introductory slides first. So, we will be doing one particular approach to the cloud that is Google App Engine, but I want to give you a very rough overview first. So, what are various types of cloud servers that we can use? Some of them are virtual machines. These are virtualized Linux servers that you can install on the cloud. You can essentially say, give me one of these machines, and Amazon or Google or Microsoft Cloud will create one for you. These are essentially virtual servers. When you press a button, they get created for you. You can decide which version of Linux to use for creating them, for example, Ubuntu or Debian or CentOS or whatever else you like. Um, and they're like a virtual machine that sits in the cloud. So they look like, when you log into them, they look like a physical Linux machine, but they're virtual, they're in the cloud, they always stay up, they're hosted in data servers, and you can create them very easily. You can install all the packages you want. And as an additional advantage, when you create one and fine tune it and you get it to really be like you like it, with all the packages and the stuff you need, you can create a disk image. That is like a snapshot of the disk. Using the disk image, if you like, you can then replicate the machine many times. Simply saying that, for example, you want to create 5 machines all based on the same image, and in this way you get 5 machines that are identical, except that they have different network addresses, obviously, so you can log in into each one of them independently, and then you can manage what to run on each one of them. This is something that is incredibly convenient for doing research. For instance, you can get these machines and run your research code on them and do whatever you want. You can also build the special machines to support your startup applications or your company applications in any way you want. And they are very, very flexible. So the pros are that these things are very flexible. They're very good for experiments. You can play with them. You have full control of a machine. The cons is that these machines are still, created and shut off individually. So it's very nice if you want to control individually what goes on, but it's a little bit less nice if what you want to do is build a scalable cloud service. Because if you're using these machines to serve web pages, which is our main concern in this class, the problem is that ideally you would like to switch on and off the machines according to the number of requests you're receiving. And there is no such automatism for virtual machines. So you need to write your own code for deciding how many machines to spin up and down, depending on the request. And you also need to configure your own load balancers. These load balancers are the machines that essentially decide or route the requests from web browsers to the virtual machines that will serve the requests. They're like, when you check in at an airline, there is this person that tells you, okay, you go to counter 2, okay, you go to counter 5. Okay, a load balancer does a similar thing for web requests. And in this case, you need to configure it yourself. So it's a little bit of work. Virtual machines can do everything you want, but not in the easiest way. And an improvement on virtual machines, if you're interested in running a collection of identical machines to serve web requests, is containers. So basically a container is a description of how to create a virtual machine. Rather than creating a real disk image, maybe 10 or 20 megabytes big, and then freezing it and say, okay, this is my frozen image of the disk, and if I want 10 machines, I replicate this disk image 10 times. This is a lot of gigabytes that get moved around. What you do is that you essentially keep the recipe list of how to build a virtual machine. So your list will look like okay, install this package, install this other package, modify this configuration file, install that other package. It's a list of instructions, basically like a kitchen recipe. And so whenever you need a virtual machine, you say, well, bring up one more machine according to this container. I will bring up one more of these containers. And the Amazon or Google or Microsoft Cloud will be happy to oblige for a price, of course. And they will essentially follow this list of recipes that translates to a list of modifications to the file system of a blank, standard virtual machine, and spin up the machine for you. So the advantage is that it's faster, because rather than dealing with disk images that are several gigabytes large, you simply explain the list of differences from a small virtual machine. And moreover, because these containers are thought to be part of ensembles that contain many of them, there is a lot of software and configuration tools around deciding the number of containers, doing the routing, creating them like this or like that. There is a lot of infrastructure available for containers. In fact, the containers are very fashionable. I think it would be very interesting to teach you about containers and container engines, which are the environments that can manage the containers you have. But I think it would require another class, or it's not very easy to do it at the end of this class. So what I want to do is instead go on a third type of cloud services that are very convenient for hosting web apps, and that are essentially of the family of App Engine. So there are three types of App Engine, but essentially the general idea is this. All the previous things we have seen, that is virtual machines and container engines, are based on the, if you allow me, old concept of a machine. This machine, the need for a real machine, like a virtual machine, is rooted in hardware. A machine is a complicated thing. It contains an operating system, it contains files, it contains libraries, OS configuration, a lot of stuff you basically don't care immensely about if all you want to do is serving web pages. So imagine that your concern is serving web pages and you don't really care about the OS nor anything else. What would you like to do? All you would like really to do is be able to say something like, okay, if I get a hit on this URL, that's the work I have to do. If I get a hit on that other URL, that's what I need to do. But you don't bother about a file system, you don't bother about a CPU and how fast it is, you don't bother about how many RAM you have. I mean, all that is meaningless, it's traditional, it's part of the history of how computing devices came to be. But it's not really your concern as a web developer. As a web developer, all you care about is how to serve web requests. And so App Engine takes essentially the point of view, okay, let's get rid of the OS as a concern. Let's get rid of everything. Let's consider only the problem of what code should run when this URL is served. And so the App Engine essentially will instantiate for you, it will take care of instantiating for you the machine on which your code actually runs. It's transparent to you. You don't basically care a lot. You simply say, hey, this is my Python code, or there is a equivalent also for Go, Java, and PHP, but we will be using Python. So you basically say, hey, this is my Python code. This is these are the URLs I want to serve with the Python code. And I don't immensely care about the rest. I tell you that I want to spend at most $10 a day, and that's it. You go, get me happy, and I don't care how. That's a bit of a simplification, but I think it is the essential idea. So the App Engine still uses some sort of virtual machines that look a bit different or very different from the normal ones to serve your code, but it completely manages the spin up and down of these instances, and it completely manages the provisioning of resources. So you basically give it a spending limit per day. You are actually given one machine per day free, so that you can host a free service, but the rest is taken care of, okay? And so it's very simple and fast to upload code. One of the things that really distinguishes App Engine, I think, and I've experimented it firsthand, is this. Suppose you have a website and you put up a version of code. So eventually you will make a mistake, or maybe not a mistake, but eventually you will want to push up a new feature. So how do you do it? Well, with Container Engine, great. So you build this container, and so now you say, okay, instead of this code, I want this other code, and then you have to build the container description, and then this goes to the cloud, and yada yada. And in my experience, it takes roughly half an hour before your new container is ready and up and running and serving requests. It seems difficult, and again, I don't know if there is a fundamental reason for that, but I can tell you that in practice this is the case in the code I've seen in at least a couple of startups. That if you use Container Engine, from the time in which you say your code is ready on your local laptop to the time when the code is actually running in the cloud, the interval of time is measured in tens of minutes, and I think it's around half an hour on average for what I've seen. Instead, in App Engine, it's measured in tens of seconds, and this creates a far more dynamic way of developing sites, right? You can say, okay, let me try this feature, and then you push it up, and you can move a few. We will see how you can move a few of your users to the new infrastructure, to the new version of code. And then, you can see how well that works. You can move them back to the original one, but your iteration speed is much higher. And so your productivity is much higher by several orders of magnitude, in my opinion. So, what are the cons of this seemingly marvelous App Engine? The cons are, so in the original version, which is also a version which we will be using in this class, you can only use pure Python modules, that is, modules that are written in Python itself and not C code. There are some exceptions from NumPy, PIL, PIL, the image transformation library. But for example, you cannot run PyTorch, TensorFlow, scikit-learn, and this type of code that really relies on assembly language and Fortran and C bindings. That's not possible to run there. The Fewer version is free of these drawbacks, okay? But the advantage is an incredibly fast iteration time. It's one of the reasons why Snapchat, which is based on App Engine, became so successful so fast. So App Engine essentially is very nice for enabling a very small team of people keeping up a very large service. And I've seen these many, many times in the startup world, where when you need to come up with something new efficiently, fast, and have it scalable to a large number of users, if you want to go fast, you use App Engine because you are free of the concerns of managing resources yourself. So I will explain in this presentation how to upload applications to App Engine. Later, I think in a later lesson, because we want to break up the material in some units, but I want to also give you a better overview of what the cloud can do for you. So the cloud can essentially take care of serving, but you can also take care of your database, so where to store data. We have already seen that this can work for storing files in Google Cloud Storage, for instance, in the previous lessons. But you can also have managed the databases such as Google Data Store or SQL. You can do traffic splitting, traffic management, where by traffic it's intended web traffic, so where to serve the requests. It can give you queues, it can give you Memcache, it can give you a lot of other services. There is really a wide set of services. So, before we go further in this talk, let us get started with something more concrete. So, here is the web page I'm preparing. I will be uploading the talk here. I give you some material. I give you pointers to an introduction to the type of cloud. I will add the talk I gave you to this page. There is a quick start guide to the Google App Engine. There is a code of the app that we will be developing, so it's in the branch 2018-11-20. If you want to follow this presentation while following the code, you can go there. And I also give the app YAML file that we have used. So let us now start from scratch on how to host something on Google App Engine. So the basis is this. We have to have an application in Web2Py that works locally. So I have it here. Let me go to it one moment, okay? It is here. Okay, I started it and you can see it here. You know, I serve it from address 8888. It's up and running. And if I look at how this works, I think you may have seen it already, but it's our classical application of the blog post. Okay, so I can log in. Let me log in fact, just for the fun of it. Okay, I can log in. Oh boy, I must have done something wrong. 1 second. Okay. Yeah. Okay, finally. Sorry. You know, I should turn all my passwords to banana. So this is the application I wrote. You know, I can delete posts. I can add a new post, and it basically works. Fine. I already talked about this application. I don't want to go into details of the implementation. Rather, I want to show you how this is done. How can we start serving it from Google App Engine? So the first step consists in installing the Google Cloud SDK on the laptop. So here I have some instructions. So here is a comparison of the various environments of Python. We will be using the first generation Python 2.7. To recap the differences between these environments, the first generation Python 2.7 is the one in which everything is provisioned for us. We purely give the Python code to be run to the cloud, and the drawback is simply that we cannot use binary Python modules outside of a restricted list comprising NumPy, PIL, and a few others. There is a newer second generation Python 3.7 environment which is just out. I actually haven't had the occasion to use it. I think last time I checked it wasn't there. I don't know how old it is, but it cannot be more than a couple of months old. And so this looks actually very promising. I want to play with it. I think the difference is that some of the libraries are not as simple as the one for the first generation Python to use. Libraries, I mean, to use Google services, but it's definitely worth a try. Maybe I will use it in my next version of this class. And then there is a flexible environment, which is essentially based on Docker, container engines and Docker. And so that environment is works well, but it's a bit longer to upload code. So it's a more involved process. And if you like, I can always provide an overview of this environment, or perhaps we can play with the second generation Python 3.7 in a later class. But what I want to do is really focus on the first generation, because I see it as an incredibly simple solution to host websites in the cloud. You can use it also in your projects. That gives you scalability and a lot of very nice features, we will see. So you have to follow the quick start, which is linked from the page. You know, quick start guide is this. So you follow the quick start for Python 2.7. So you need to create a project. So you need to log in into the cloud and create a new project. This means you go to console.cloud.google.com and you create one of these things. I will be using Luca Teaching as my project, but you can create any project you want. The name has to be globally unique in the Google namespace, but the name doesn't immensely matter, because if you later buy your domain name, users will not see your project name. So you can also call it like, I don't know, Banana Smith Happy Project for a nice week altogether, right? Maybe you want to choose less silly a name, or perhaps a shorter name, but essentially the name doesn't necessarily matter a lot. It's just like an ID. Okay, so you get the project. You may have to enter your credit card because some of the services cost money, but you can generally either not switch them on, or in the case of the basic serving, you can say how many dollars at most you want to spend per day, and you can set it to 0.01. And you get a free instance per day, so that you can always serve moderate amount of traffic for free. So it's pretty good actually. I don't get free coffee, so you get free computing, so you should be happy in a sense. So great. So you create a new project, then you go to App Engine and you need to create a new project. This means you need to go to App Engine, but if I go to App Engine, I have already a project, right? So to me it appears this. If you don't have any project, there is a button to press and you get your project. Fine. You download the SDK, you follow the instructions, and you install this gcloud command. And you install also this App Engine Python component. Great. Now you instead don't download the Hello World app, because after you have done all that, I can teach you how to modify your Web2Py app so that you can actually use it and upload it to Google App Engine. Okay? So let's do things one by one. The first is this. You have your regular app. Okay, let me close this so we focus only on the top level details. So this is my Web2Py directory, in which there is hey, my mouse is frozen. No, there is web2py.py. There are many things, and I created a file called app.yaml. Actually, I didn't quite create it. What I did is that I took a version that is in examples. There is a version called appexamples.yaml, this one, and I modified it according to my needs. And the version that I have here, I give it to you also here, so you can download it to see exactly what I did. Okay, so once you're here, the file works as follows. There are 4 important things here at the beginning. This means I want to use Python 2.7. My API version is 1, which I don't know what it means, but I think if you change it to something funny, you would I don't know, blow up, or maybe use another version of the framework. You don't write these things. It's like, what happens if I press the red button, right? You don't do it. Or maybe you do it, I don't know. But I didn't in this case. Thread safe is equal to true means that you can run the thing with multiple threads, which really has no drawback because Web2Py is also able to deal with multiple threads at once. So don't worry, let's just leave it to true. Default expiration means this. App Engine is good at caching static files so that it doesn't send them each time to the browser whenever the browser accesses a page. We discussed these towards the beginning of class, right? If you have an image or if you have a CSS file, the file is mostly cached, and so if a browser visits twice in a row your site, you don't give it each time the CSS because it's not changed. Now, in the App Engine implementation, this is implemented in a way that I find a little bit suboptimal or tricky or whatever you want to call it. But essentially, App Engine is as if it's a very sleepy giant, and it doesn't realize in a short time when you change your static files. So you have to essentially give it the amount of time it can hold on to old static files before it realizes App Engine that you have changed the code in App Engine itself. So unfortunately, the default of this default expiration is 24 hours. This is bad because this means that when you upload your code, if you change your CSS, the old one may be cached up to 24 hours before it's served to anyone. This is a disaster, right? You cannot update your code in that way. So I set it to 1 minute. You can also set it to 10 seconds. It's your choice to how long you set it. But if you should set it very short, the caching is not very useful. But 1 minute, I think, is a reasonable compromise for refreshing your site. Now, from here on, from here to here, it's boilerplate. Don't touch anything. The only thing you may want to touch is libraries. I here have PyCrypto and YAML enabled. You may want to add other ones. You can add Pil and NumPy. Ask me for examples if you need them. But essentially here you can list a small set of additional libraries that use C code that are whitelisted by Google App Engine if you need. Okay, so you created this file that looks very bland. You can mostly copy it from one application to the other. It doesn't contain anything that is really specific to our application. In fact, what I did is actually I copied it from some other place. I had one lying around and I copied it. That's why I use PyCrypto. I don't need PyCrypto for today's examples, but I copied it from a place that had it. I copied it precisely from the application that I built to upload files to GCS, if you are curious. The one I discussed in class some time ago. So at any rate, you take this zap YAML file and you just slap it in the home directory of your application. Okay? The same directory where there is web2py.py. Great. At this point, you do something. That is, there are some very minor differences in how to run your app. The web2py command that we use here, right, and that you have been familiar so far in class, the one that generates this window, essentially uses SQLite as the database. On Google Cloud, you have the choice of what database to use. We will be using Datastore in these examples because Datastore is free, but you can also use MySQL. So, to simulate the app as it will be when it's running in the cloud, it may be convenient for you to run it. I'm sorry, I need to find here with a slightly different command that is called and is documented in the cloud. Let me show it to you. Is called dev app server. I said dev app server of app.yaml. Just as you say Python web2py.py for running it under web2py, if you do this dev app server.py app.yaml, you are simulating the Python as it will be run in the Google Cloud. There are some tiny differences, and you may want to write it in this way as well. So this wakes up, does a lot of your mumbo jumbo, and then it tells you, okay, starting module default at localhost 8080. And in fact, if you go to localhost 8080 here, you are running the service as simulated by the local Google App Engine. Okay? I don't show you how to log in and do things because, it's basically the same. Great. So now we have a version of code. You can play with it. You are encouraged to play with it before you deploy it. But you can play with it either powered by Web2Py or powered by the local dev app engine, devappserver.py, and you gain confidence that this works, and now you want to upload it to the cloud. So how do you do it? Well, use the gcloud family of commands for doing it. 1 second that I go to the appropriate window. Okay, so gcloud. So if you don't know what to do in gcloud, you can always say gcloud help, and this will print out some help messages that tell you everything you want to do. But One thing you can do is list your configuration, and let's look at some of the parameters here. You need to choose the account. You can say, gcloud config set account, and then you can say which account you want. You can look at the documentation. I set my account, my Gmail account I'm using for these things out of tradition. I could use you can use your ucsc.edu account. It's a perfectly good one, except I'm not quite sure what happens when you graduate, so I don't know. You can set the project to be the project you want to be using. This Luca Teaching project is the same as the project here that I have in Google App Engine. Okay. And then there are a couple of things, this disable usage reporting. I really don't know what it is and how I got it here, but I don't care. This promote by default essentially means when I upload a new code, I don't necessarily want to become the new code to become the one that will be used to serve new requests. I usually like to go a little bit slowly so that when I upload the new code, I want to decide if and how to use it. I don't want to just by default route all the user requests to the new code because, maybe I want to do a little bit of testing before I do that. Okay? So in order to upload my code, the command I use is the following. The command is this. gcloud app deploy. This is documented, by the way, in the same quick start guide I told you. I give it the version. The version is my site. I tell you in a moment what the version is. I give it the project. And I say, do not promote by default. And then I say app.yaml. Okay, so this locates the file, the app.yaml file of what I want to deploy. The version, think at it a moment as, well, let me show you what happens and then I tell you what the version is. So if I do this prints essentially a confirmation prompt that says, the descriptor is the app.yaml file, the source code is in this directory, great. The target project is Luca Teaching, that sounds good. The target service is default. Services are a sort of advanced concept in Google App Engine. You could divide your app in multiple services and create settings for each one of them. It's fairly advanced a feature and we will not get into that at all. So for the moment, service is gonna be always default. Now, target version is my site. That's the target I gave you and the version I gave you, and I haven't told you what it is, I know. And target URL is this. So this is what a version is. I essentially have an app that is called Luca Teaching, but Google App Engine is fairly great in that it doesn't give you just one app where you can serve stuff. It gives you essentially an infinity of apps, even for only one project, because for each time you upload the code, you can specify the version. I specify my site. And then, corresponding to the version you choose, you get a URL. So you see, it's magic. I get my site and I get a URL for my site. I get, I want to upload some entirely different piece of code. I give it a target version of, I don't know, Happy Rabbit, and I get https://happyrabbit.lucateachingapps.com. And so I can host an infinity of quite independent web applications all on the same project. Okay? And this is very, very nice. Essentially, it's as if instead of having to have only one application hosted there, you can have multiple in parallel, each one with their own main URL. This is a little bit the same as Web2Py does, right? In Web2Py, you can have multiple applications. Well, a version is exactly like a Web2Py. It's similar in concept to a Web2Py application. It's an entirely new place where to store your app. So if I say yes, these things a moment, uploads the service, yada yada, moment. So now to us it looks slow, you know, what is it doing, uploading the service, whatever. But what it is really doing is fairly magical, because it is bringing down all the virtual machines that were serving the old code, and this could be hundreds if you have a very active site. It's replacing the code version, and it's ensuring that all the new machines that get spin up according to requests are serving the new version of code you have just put up. Okay, so now we can go look at our application. We can go to the URL corresponding to it. So there we go. We wait a moment because it needs to spin up a new virtual machine, but it's very quick. Okay, there we are. And so if I go here to start, that's our code. I just yeah, this is me playing with it before. I can log in. Oh, I hope I remember all these logins. Logins are the ban of computer science, or my ban at least. Okay, fine, I could remember it. Okay, so we are in. I can start things, I can delete some other posts, I can do exactly what I want. This is served by the cloud. Very simple, right? It's the same thing we had locally. So there are a couple of differences, but let me get to them a bit later. First I want to show you one thing. If we go in the App Engine console, we can look at the versions. So this is my site, and these are all the other versions I have. Okay, I think I have only 11 here, but I could have a bunch. Each one of them can be served by a number of instances. Here, since I don't have a lot of traffic, I have at most one instance that is up. Okay, and I pay for even less than that. If I go to the dashboard and I can ask for the instances, it tells me how many I have created, which is 5 now, oh my goodness, because I've been playing a lot, but also how many of them have been billed for, which is very few. And so I can look at the day, and in my whole day, I have a spending limit of $5, but I used only 2.3 instance hours, and because I have 28 free of instance hours, I'm not spending any money on it. Okay, so this enables you to bring up services for free for a small amount of traffic. Okay, so if I go to the versions again, each one of these is a website, and if I click here, I can visit them. You see my new version.looker. I can also delete them, I guess. Boom. Delete my new version, yeah, delete it. Kaboom. And so it's gone. No, well, it takes time, you know, whatever. But the idea is also this. Suppose I have my site, and I want to change a feature of what I'm doing. Okay, so I want to make an improvement, but I'm not quite sure it's going to work well. What do? Well, I do this. I do an app deploy again, but I say, instead of my site, I can say my new site. Okay, my new site. Oh boy, no, I don't want to do this. I want to call it my new site. 1 second. Okay, 1 second, this will upload it. Then I can go to my new site. So I'm bringing essentially a new version of code up independently. Okay, 0 files uploaded because it knows I haven't changed anything, right? Normally would upload some file. So now it's updating the service. Come on. Come on, come on. Yeah, I would check the laptop, but I don't think it will work to make it any faster. I wonder if those characters are braille that moves there. Oh, done. Okay, great. So now, if I go again to the versions. I need to refresh, I guess. Okay, here is my new site. Now, these have the same copies of code, okay? But I could, for example, decide to split the traffic and say, okay, my site, like, I add a version and I can say that my new site will receive 5% of the traffic. Okay, so if I do something like this, this you can decide whether to split the traffic based on IP address, cookie, or random. But now 5% of the requests will go to my new version of code. So if you are updating a website, you can essentially move 5% of the visitors to the new version of the site, and you can check that the site works for them. You can look at the logs and you can check that nothing bad happens, okay? And you can do the split by IP address, by cookie, or random. Random, I believe, it means random for each request, which is perhaps not so great, because if you do it totally random, you know, if your cookie is related, I don't know, there may be state that depends on the version. I would generally encourage you to do it by IP address and cookie unless you really understand what you're doing. Okay, so what is this traffic that you're splitting? In this case, don't want to save it. Oh, okay, saved it. Okay, fine. So what happens if you take a version and you can say that I want to migrate all my traffic to that version? What it means is this. We have seen so far that we can access this my site via mysite.lucateachingapps.com. But in fact, you also can access it via lucateachingapps.com. This will be the default URL. And if you do these, then this goes by default to the default version that you have defined. One thing you can do, by the way, is that you can go into settings, you can buy a custom domain, such as myapp.com or whatever it is, and you can add it. You need to verify that you own it, okay? And you can even get a SSL certificate for free, which is great for two reasons. First of all, an SSL certificate to be able to use HTTPS on your domain will cost you about $80 a year, or maybe $60, depending on what you buy, at the minimum, for each domain. The other problem is that managing SSL certificates is very difficult. I mean, it's not very difficult, it's a tiny bit difficult. But the problem is that if you do it wrong, your entire site goes down. So it's one of these things, for many things we have a lot of redundancy in computer science, right? I can upload a new code version, I can move some of the traffic to it, I can move it back to the old version if the new version of code is not right, and yada yada. If I upload an SSL certificate and it's misconfigured, all of a sudden, all the people that want to access via HTTPS, which may be mandatory for some of the things you may be doing, cannot access your site anymore. And you don't have any backup. So it's a sort of high wire act to replace an SSL certificate, unfortunately. Even Google did it wrong, in fact, some years ago. There was a glitch by Google of a few hours some time ago, I think even something ago, in which they forgot to renew google.com or something like that. Yeah, I'm not joking, actually. They lost their domain for a quick amount of time, the SSL certificate, and so, you know, they were in trouble because they needed to get the certificate up and running. There was one such mishap. Okay, so getting the SSL certificates is actually one of the huge advantages of hosting your site on App Engine. We don't need this for this particular demo, okay? Now, another thing that that the cloud gives you is and I know it seems trivial, but is very much non-trivial, is logs. So we can look at the logs and we can decide which logs to look at. We want to look at the Google App Engine logs for the default service for my site. And this gives us the logs. Now you may think, oh, big deal. I mean, we have the logs all over the place. Well, it's not really a big deal, a small deal. It's a big deal. Imagine you have even only 10 front-end servers that serve requests. There are two problems. First of all, if I look at the logs by user joe@ucsc.com, I don't know typically if I keep these 10 virtual machines separate. I don't know which one of the 10 different machines served the requests by Joe. Not only, imagine that each request by Joe causes 5 log lines. No, because I may want to log the initial request and some intermediate results before I create the answer. The problem is that a single front-end server will be servicing many requests at the same time, not only one, right? They have parallelism. Multiple requests get served. So if you do the trivial logs on a server, the log lines from different web requests will be interleaved, because they will be strictly in chronological order. All this makes for a huge mess, so the logs are basically non-functional, and in fact there have been companies whose basic business model is to organize your logs to make them searchable and organized. App Engine gives this to you for free. When you look at a request such as start default index, so first of all, I mean, the requests from all the front-end servers get collected into a single log. The log is searchable. I can search by text that appears in it or whatever. For example, I can search for Luca at ucsc.edu, and this will give me all the requests in which there is a piece of text that logs Luca at ucsc.edu, and the same for anything I want, right? So this is completely searchable. Moreover, each one of these requests contains in order all the log lines of the request itself. In this case, you may see it's a bit trivial because I only have 2 pieces to the log line. Okay, but in realistic examples where we are not developing toy apps and you may have more logs, this will collect all the logs from all the log lines from a single request in a row to the same place. This is an amazing feature for keeping a service app. For example, in CrowdGrader, whenever one of you tells me, hey, Professor, the dog ate my homework, no, not quite, but, I uploaded it, but it threw an error when I did this or that, I can essentially enter your email address here, I can search, I will find all the requests that you did in the last, depending on how long I keep the logs, and they will be able to see any errors or debug any problem that happened to you, okay? And this was fundamental, for instance, in debugging CrowdGrader. I can also see all the errors. Here we don't have any errors. But having this log service is absolutely great. Another thing is that when you use Web2Py locally, of course, you have access to the database via the admin app of Web2Py. Here, the database, here we are using Google Data Store, as we mentioned, and so it's here, the database is Data Store. I can view it, I can view the entities, and there are many entities, also because I use the same Data Store for many of the, for a lot of experiments. So this is my teaching site, so but for example, I want to look at the post. Okay, these are my posts, and I can look at one of them, I can edit them. Now, basically, it gives me an access, a way to manage and check my database. This, I tell you the truth, is most useful for debugging at the beginning, because after a while, these databases get very large, and it's not that I really, once I have billions of entries, go into each one of them and say, oh, okay, this looks like that. But for debugging is good, I guess. So, which brings me to the one point of difference between hosting these in the cloud and locally. That is, in the cloud you have a choice of which databases to use. We are using here the data store. The data store has some advantages and some drawbacks. Let me fish out a slide I made on these. Here. So the data store is a NoSQL database. It's a non-relational database. It's very scalable in both storage and bandwidth. The idea of the data store is that the data you store are divided across many machines. So when you write to it, you don't necessarily route all your writes to the same machine. For example, in my startup Cameo, we use the data store to store essentially individual events or individual images or individual whatever that every web camera uploads. But we can service many web cameras, many thousands of web cameras, and they may upload a lot of stuff every minute, every second, in fact. And we wouldn't want to route all the information to a single machine because quite simply we could overload the network link to that machine, right? The machine can be a bottleneck essentially of a web application. Or to give an even more impressive example, think that Snapchat is essentially implemented on this infrastructure. So think around the Thanksgiving or Christmas or New Year or one of these periods where everybody Snapchats. Think of the millions of images per minute probably that are uploaded to Snapchat. You certainly wouldn't want not only the images, but not even the metadata to go all to the same machine, right? You could easily overload it. So this is data store essentially runs on a geographically replicated and highly distributed infrastructure of servers. So it scales incredibly well. What are the problems? And problems is perhaps unkind. Let me fix it. I should say like drawbacks. One is no joins. We saw already that I had to translate my original code here in API.py. I had to translate this code, you can see in part 1, in such a way that I avoided the joins at the price of a few more queries. Also, there is a more serious limitation. We can have in each query only one field where the inequalities are used. For example, I cannot have a query that says all posts since January with more than 3 stars, because there would be an inequality on the date and an inequality on the number of stars. I can say all posts since January with 4 stars. I can say also all posts since January with 5 stars, and then I can take the union. But I cannot do a single query. And so if the fields are floating point of dates, this is a problem. For another example of query you cannot say, imagine that you compute a floating point ranking, a floating point quality for each, for each blog post, and based on text analysis, whatever, right? You cannot say, give me all the blog posts with quality greater than 3 and with date after January. That you cannot do. You cannot ask, give me all the people that are taller than 5 feet and heavier than 100 pounds. That you cannot do. So those are serious limitations, essentially. You have to find a way to either rephrase your queries in something that Datastore can answer, or else you have to use databases that are not Google Data Store. Okay, and I think in a later session I will show you how to use Google Cloud SQL. Basically, there is nothing complicated about it. I can show you a little bit now. Now, perhaps. Oh, sorry. But the problem is that Datastore is free for small usage, but Cloud SQL is not. So there is another sort of subtle drawback to Google Data Store. That is, when Google Data Store inserts data, because it is so large and because it is so distributed, the indices are not always local to where the data is. which means that sometimes you can add data that only later is accessible via indices. By later, I don't mean 1 week later, but I mean perhaps even up to a second later, if your amount of data is very large. This means that when you insert data, suppose you insert a new blog post and then fetch the blog post list immediately. This may not work. So when you insert data, there may be a delay of up to a second typically. You know, Google doesn't give you a specification, but I've observed up to a second or so before the data is again accessible via queries. So if you built a website, and I built one as a test, right? I haven't been able to trigger this behavior because my data set is too small, but I want to show you one instance where the behavior can give you trouble. So I built a page at default start, instead of index I called it posts. No, sorry, this is a wrong window. Let me do it here. Posts. Okay. So this uses an SQL form.grid to show me the list of posts. Now I can add a record. I can say that this is my post title, this is my title. The post content is my content, just to be fast. And then think a moment at what happens now. I'm posting this form and I'm reloading a page based on a query. This works locally. This works locally and the post is here. Great. Now, I tried these on the basis of the Google Cloud implementation. Where am I? Here. So let me add a new post. I can go here as well to posts. Okay, and once I am in posts, now I can say, I'm not logged in. Okay. Wait, okay. One sec. Okay, now I'm logged in. Okay, now I can add a record. Let me call it again my title and my content. Now, if I click submit, okay, this time it's here. And again, it's because my database is small. But if I had a larger database, these often would be missing. Okay? And it's because the data you put in, there is a delay before you get it out. Now, the kind of good part about it is that I taught you how to build sites that are based on Ajax. So if you go to like to the Ajax page we built, if I say yet another post and yet another content, now when I click here, the thing is different. Before, we would first insert and then immediately do a query to generate the page. Here we don't do that. When I click submit, the new data is sent to the server. But the post is added to the post list locally on the browser. So we do not rely on doing a search. In fact, we do not search when I click submit. We purely insert something on the server. Okay, so there is no doubt, even though we use Google Data Store, that when I do click, the yet another post with yet another content is going to be here. Okay, and we do not depend on the behavior of Google Data Store or its speed for having this data here. So there is an advantage essentially in using Ajax, because when you insert data using Ajax, you produce the effect client side and you do not need to rely on answering queries very quickly. So in general, when you use Ajax, you are not dependent on being able to immediately query for what you have just inserted. Okay, so the Google Data Store essentially works well using Ajax, but may not work well when using things like the classical model view controller way of developing. Okay, now as I mentioned to you before, you can also very well use Google Cloud SQL. In fact, I use it for CodeGrader, and I'm incredibly happy with Google Cloud SQL. It really works absolutely great. The only problem is that if I want to create an instance, and I can create it with MySQL or Postgres, I need to pay for it. Okay, and so I can give it an instance ID, I can give it a name, I can say what the root password, where the location is, where the zone is, and I create it, and this gives me a completely managed Cloud SQL database. And I will post on the class documentation how the URL that you use to connect to these instances. The pricing is also quite convenient. Google Cloud SQL pricing. So if you use these, for example, for MySQL, okay, second generation, assume. We want to know it monthly, obviously. And so if you use a small instance, it's $25 a month. A micro instance that is good for testing is like $8 a month. This is peanuts, you know. You can have coffee once a week for the cost it keeps you, for the cost that you have in keeping an, what is it, 3 terabytes maximum storage. That's a huge amount. Instance in the cloud. So this is, I think, fantastic value. And it's completely worth it, because not only this is not the pain of keeping up your own database server, but these databases are also geographically replicated. So you can have replicas that are configured automatically and kept automatically for you, so that if you lose your main database server because, I don't know, because something happens to it, or it's very rare. I haven't lost any servers so far, but if it ever happened, you would have replicas that contain immediately updated the same content of the main database, so you can essentially have no downtime. Amazon also runs their own managed databases. I have to say, I'm quite a fan of the Google Cloud. I think it's incredibly nice. I think it's very secure, and I'm a complete fan, and it never failed me. But it's not the only one. So Amazon also has a very good cloud that in fact is larger if you measure it in number of clients and revenue monthly. And so the only thing is that if you use one of these instances, then you need to adapt one place. The place is here. In db.py, at the beginning, there is this if-else. This says, if we are not working on App Engine, and this is all you have been doing so far in class, you have always been taking this branch of the if-then. So if you are not on App Engine, then we use this database, which in practice, because it's defined in myconf, and myconf is, let me show it to you. myconf is in it's here, okay, because the URI is an SQL URI. You are connecting to an SQLite local database. Okay, that's what you have been doing so far in the whole of the class. Now, here instead, if you are on Google App Engine, now we are running this line, which means my database is the Google Data Store, which is really convenient for all the reasons I told you. However, if you don't want to use the Google Data Store, but you want to use the Google Cloud SQL, then you need to use a different connection line. All you need to change is a string here that will identify the Google Cloud SQL instance that you have created. Now, I don't remember by heart this string, but I can post it on the class web page. I need to copy it from some place that uses it, and I cannot look it up now because I'm afraid that the actual string actually contains a password, and so I need to sort of look it up and then post it on the web rather than go browsing now in my file system, I guess. Okay, but and so the difference is to you is essentially this: if you use Datastar, you get this completely free service, very scalable, very nice, but that has the limitation of not doing joins, and it has the limitation of not supporting inequalities of more than one field during a query. If you instead use SQL, well, then you're in business. Everything works normally as it works in all the code you have written so far. You have the full expressive power of relational databases with the joins. And I find it very rewarding actually to use Google Cloud SQL. So I've built CloudGrader based on it, and I've built other sites based on it. The other difference is this, by the way, that Google Cloud Data Store, it's incredibly scalable if your wallet scales, meaning that you pay by request and you pay by write. And if you write a field, let me go back to the web console. So if you look at an entity, let's look at our posts again. If you look at a post and you look at the details of one of these posts, you see that a post has various properties, they call it the fields, and that some of them are indexed. This means that when Google Cloud Storage bills you, it bills you for when you add one of these posts, you pay for one write for the whole post, and then 2, 3, 4 writes for the index, 4 writes in total, okay? And if you look at the pricing, it will cost you Google Data Store pricing. Google Data Store pricing. Okay, it seems cheap, but it's not quite, because it's 18 cents every 20,000 writes, and that's not a negligible amount of money if you do a lot of writes. I've found by personal experience that SQL databases are up to 10 times cheaper if you have a lot of writes. I mean, an SQL database can easily support, I'm doing a project on fake news detection, I support 500 writes a second because we have a very high volume of data coming in. And this thing is costing us $30 a month. Now, if you do the calculation, 500 a second, let me actually try to do it. I should have prepared it, but I haven't. So 500 a second. Sorry a moment. 500 a second times 3600 in an hour is already 1.8 million times 24. So we are doing 43 million writes a day. And if you divide by 20,000, we are doing 2,160 of this pricing times 0.18. We would be spending essentially $389 a day writing to our database. We would be basically bust. And instead, we essentially spend $1 a day. So essentially using MySQL is 400 times cheaper for us than the Google Data Store. Of course, the Google Data Store gives you incredible bandwidth that we wouldn't be able to have for MySQL. This said, I have a little bit of trouble in general justifying the data store, except perhaps for the free tier, which is probably what will be relevant to you, because you get free usage below a certain number of writes per day. So they give you a free quota per day. They give you oh, actually, this is imprecise. I don't know what a unit of writes is. I think it's probably this, but I don't know. Okay, I should have gone check better. Sorry. Cost per hours per instance. Okay, I should have. Okay. And it depends on where it is. Ouch. And it's not. This one. No, oh, yeah, per 100,000 entities. Yeah, so it was off by a factor of 5. So instead of $400 a day, this would only cost you $80 a day, which is still, a lot more than the $1 a day I pay. Yeah, so it's still widely non-convenient actually to use the data store compared to MySQL if you don't exceed the total bandwidth. Okay, so I hope this gives you a quick tour of how to deploy apps on Google App Engine. Again, the main points to remember is this: it's quite easy to upload. Okay, it takes just a few dozen seconds to upload a new version of code. You have essentially unlimited applications you can serve because when you have the various versions, you can have many versions of code, and you can decide which one is the default one for serving. If you had a custom domain or from the basic URL, but otherwise you can have many versions of code, and you get essentially one virtual machine free every day. So you have essentially 28 hours of uptime of an instance every day, however you decide to split them, however bursty. So I think that this is a very nice service, and for your project, if you want to host it on App Engine, I think it will be a very nice learning experience, and it really gives you one real weapon in your arsenal as a web developer, sort of, because there are a lot of these people that think that, oh, okay, I need to have a virtual machine, otherwise it doesn't work, and then they have this complicated app delivery and update cycles. And this gives you essentially an extremely flexible way of hosting a lot of services online with very little waste of your time. And so I think it's very worth knowing. Okay, thank you. Okay, bye.